we start with what is called section rational expressions, section 1.6 from the book. And today is the 27. Can you see from the back? Okay, so 1.6 rational expressions. Rational expressions. Please stop me anytime you have a question for any reason. Okay, so we decided to work on problem 19, and this is on page 64. 2d squared plus 15d plus 25 divided by 4d squared minus 25 and multiplied by 2d squared minus 15d plus 25 over 25d squared minus 1. Okay. This is a rational expression. It's a ratio of two polynomials. Ratio of two polynomials. What is this? Another rational expression, of course. What operation we have to perform with two rational expressions? What do we do? Perfect. Okay, what are the options here? What is the first step? How do we think about this? We identify them correctly. They are rational expressions, and we want to multiply them. What do we do? Yes, please.
Do you simplify them by factoring?
Excellent. Did you hear? Simplify by factoring. Okay, which means that I cannot simplify 25 with 25 because 25 and 25 are or are not factors. They're not, they're terms. Correct. So 3 terms, 2 terms, they're not factors. We can simplify anything but factors. If you didn't remember that, please write it down as a note. We only simplify factors, not terms. You want me to write it down with you? Okay, note. Simplify only factors, comma, never terms. And in case you forgot what that means, so A times B, because they are multiplied, these are factors. But A plus B or minus B, they are called terms. Very good. So we have to go back to the first rational expression and try to factor the first, second, top, bottom. Okay, so let's start with 2d squared plus 15d plus 25. 2d squared plus 15d plus 25. How do we factor this? There are many ways. I'm not sure which way you like. I'm not sure which way you were taught. I'm going to show you my way, and then I should have mentioned this. I may show you a particular method. If you know your own, if you know a different method and you are comfortable with it, do not switch to mine. But just watch and see if mine is easier, then use it. If mine is not easier, stick with your own. That's fine. Okay, so in this situation, I see this is a trinomial. This is how I think. Trinomial. Second step, I ask myself if it's in descending order. Is it in descending order? Yes. Third step, I ask myself, is there a common factor? Greatest common factor. Is there? To all three. The answer is correct. You're right. No, there is none. Good. Number 4. You may have taken this into account in the past or not, but this is very important. Negative leading coefficient. Is there a negative leading coefficient? No. If there were, we would have factored it out before factoring. And the last step for this trinomial, I'm asking myself, can I use a special product? Can I use a special product? Do we remember the special products for trinomials? We will come back. Do we have this form? Do we have this handout? We may not all have it. I kid my students with this by saying that this is an agreement that it will never expire. So once we agree on these three special products, you will never forget them. You don't have to give it to me, you just, let's work on this for a moment, and then we'll come back and continue. Okay, do you remember, what did we say about a plus b? What is a plus b? It's a binomial. Two terms, right? Perfect. Okay, can anyone tell us, you can just write it down in your notes. Can anyone give us the answer to a plus b everything squared? Yes, please.
A squared plus b squared plus 2ab.
Very good. So a squared plus 2ab plus b squared. This is extremely important to remember moving forward. However, what I would like you to remember is not a and b. I would like you to remember it like this, and I'm going to write it for you. First term, whatever it is, it's not going to be a, plus the second term, whatever it is. The answer is the first term squared plus 2 times the first times the second plus the second term squared. This is how we should remember it. So this is our first special product. First term plus second term, everything squared, equals the first term squared plus 2 times the first term times the second term plus the second term squared. You can say, why do I really need to know this? I can always spoil it. True, but when it comes to factoring, because that's what I'm getting at right now, it's going to be difficult to go back. If you don't understand this formula going backwards, we're going to have difficulties when we complete the square. We're going to have difficulties when we get to the circle formula or equation. So please remember a plus b squared is the first term squared plus 2 times the first times the second plus the second term squared. Okay, can anyone give us the second one? Yes, please.
A squared minus 2ab plus.
Of course. And can anyone give us the last one? Yes.
A squared minus b squared.
Very good. So this is the difference of squares. And you can say, what does this have to do with what you were doing a minute ago? A lot. Okay, any questions for me? Please stop me if you have any questions. Any questions? Any questions? Okay, so coming back here, so now you understand what I'm asking by special product. There are only two special products for trinomials, just these two. I have to check whether I can use one of the special products here, either this or this. Of course, I'm not going to even think of the one with minus because the middle term is positive. But I am going to think whether this is an option. That's my next step. But this is not a perfect square. I see cell phones in the back. That's the second time. 25 is a perfect square, but 2d squared is not a perfect square. So I will say, when I ask myself, can I apply a special product? The answer is no. So I'm moving on to the next step. And the next question that I have is number 6. And in number 6, I'm asking myself, is 1 the leading coefficient? And the answer is no. 1 is not the leading coefficient. The leading coefficient is 2. Final question. I got to this step. where the leading coefficient is not 1. And what the method I teach here, it's up to you, you don't have to use this method, is to multiply the leading coefficient by the last term, so 2 times 25. I'm looking for two numbers whose product is 50. This is the product, and whose sum is 15. So same two numbers, the sum is 15. Can we find two numbers? And here's the next step, very crucial. I look at the product first. If the product is positive, I know there are two options. Both numbers to be positive or both numbers to be negative. But once I look at the sum and I see that the sum is positive, then I know for sure that only one option is possible here. What is it? Both are positive. So please understand here, I always start with the product. Because it's positive, both numbers are positive or both numbers are negative. But the sum is 15, so this is not an option here. So now please tell me whether we have two numbers whose product is 50, two positive numbers whose product is 50 and whose sum is 15. Agreed? You have the same thing? Very good. So the next step is I rewrite 2d squared plus, you said 10 and 5 or 5 and 10, it doesn't matter. 10d plus 5d plus 25. In the next step, I will factor by grouping. It doesn't get more difficult than this. This is the most difficult type of factor. A trinomial that is not a special product and it does not have 1 as the leading coefficient. Okay, so do not go back and combine these two because you're going backwards, right? So you want now to factor by grouping. You know it's factorable. How do I know it's factorable? Because I was able to find two numbers whose product is 50 and whose sum is 15. It's guaranteed to be factorable. So from the first two, what will you factor out? Very good. What is left in parentheses? D plus 5. I refuse to look at the other two. What should come out from the other two written in parentheses? Mandatory. In parentheses.
Please be plus 5.
Exactly. Otherwise, I can't continue. That's the point I'm making. Do not look. You may make an error. When you do, you factor something else and you stop because it's not working. First, write it. Write the d plus 5 first. And now let's figure out what we put outside. I need a sign and a factor. What is the sign and what is the factor? Indeed. So now the common factor that gets pulled out is, indeed, that's the common factor in these two terms. D plus 5 is. And in parentheses we have 2d plus 5. Well, obviously, if you write 2d plus 5 times d plus 5 is the same thing, because 2 times 3 is 3 times 2. It doesn't matter, right? So please remember that. All this work was for this. But it was the first example, so of course, it takes me longer to explain till, we finish the first one. But then the second one will take much less time and so on and so forth. Okay, so now let's work on the other one on the top, the 2d squared minus 15d plus 25. See what you get. 1 minute. And then we'll put everything together. Can I get your intro? I'm trying to remember your names as soon as possible, if you have it. So we go by Handout. Yes. Okay. Okay. Very good. Very good. Okay. If you need more time, that's fine. Did you email me? Or somebody else? Okay.
Okay, I have two comments.
You know him? No? Okay. Connor? Meet Connor.
What do you do now?
Does it work now?
Oh, yeah.
Is it Michael?
Oh, yes, of course. Oh, you didn't? Okay. Okay.
But I need to find the
That's under her stuff. Okay.
Thank you. Correct me if I mispronounce your names. I don't want to do that. Maybe. Yeah. It was pure luck. Sarah. Pure luck. Do we have an answer? Do we have the factor form? Thank you. I have one of my students in my in calculus one. His name is Kyle, and he was in my pre-calc class. And every time he wants to say something, I say, anyone else but Kyle. This is so good. Elmer? Very good. Jan? Very good. And Robert. Rob, thank you. Thank you, guys. Yes. Thank you. DJ? Deja. Thank you. Thank you. Okay, good. So do we have the factor form for this?
Yes.
What is it?
2d minus 5 times d minus 5.
Do we agree?
Yes.
How do you check? It takes a blink. 2d squared is right here. Negative 10 minus 5d is here. And negative 5 times negative 5 is 25. Do we all agree with this? Do I have to show this? Do I have to show this, or do we agree with this?
We agree.
Excellent. Good. So finally, let's put everything together. So here's what we have. I'm going to copy the problem one more time. Which page am I on? I'm on 3. Okay. So we have 2d squared plus 15. You don't have to copy it. I just need to do that. So it's 25 times 2d squared minus 15d plus 25 over 25d squared minus 1. So we already have the two tops because those were the most difficult ones. So we have d plus 5, 2d plus 5. And we have 2d minus 5 and d minus 5. Okay. So now let's discuss the denominators. And now you know why I went back to this. Why did I go back to that? Because of the difference of squares. So when we multiply two binomials that are identical but have just opposite signs, we get a difference of squares. When we factor the difference of squares, this is what we get. So it was much easier to review it first. So then, how do we factor 4d squared minus 25? This is a binomial. I go through my steps. It's a binomial. It's in descending order. There is no greatest common factor. There is no negative leading coefficient. And I'm asking myself, so this is the only difference here. It's binomial. I'm asking myself a special product. Well, that is a special product. How do I factor 4d squared minus 25?
Two D
2d
plus 5.
plus 5,
2D minus
2d minus 5. Do we all agree with that? Okay. So how do I factor now 25d squared minus 1?
5D minus 1. 3.
Yes. Does anyone have difficulties with this? Okay. Now, it's extremely important to understand that we are not allowed to simplify unless we state that a factor is not 0 or a denominator is not 0.
What's your J for? That's a 5.
It's a 5. I'm so sorry. This
Alright,
one?
no, you're fine. I just-
Sorry, my apologies. I'm standing when I write, so that's not an excuse, but my handwriting is not perfect anyway, even if I sit. Okay, so this cannot be 0. This cannot be 0. This cannot be 0, and this cannot be 0. Why? Because division by 0 is undefined. Let's write a note in case you forgot. Please be careful. Note. We say undefined, but we basically say it doesn't exist, but we prefer undefined. Division by 0 is undefined. If you want to remember it as not possible, if you want to remember it as not existing, whatever. But it's not a number. We don't have a number for this. Okay, very good. So when I said 2d plus 5 not equal to 0, I move 5 and divide by 2, so therefore d cannot be negative 5 halves. Are we comfortable with that? Is that okay? Okay. So can anyone give us the restriction for this? D not equal 5/2. D not equal for the next one. Very good. And the last one, D not equal? Yes. Do not be shy, please. Let me know if you have any questions on this. Do we understand? We move the free term and we divide by the leading coefficient. Now we are allowed to simplify. Only common factors and only top with bottom, and also across. Never bottom with bottom, of course, and never top with top. My students never cease to amaze me. Every semester, I think I start a new academic year or a new semester, and I say I've seen it all. And that's never the case. They always come up with something. One student simplified something from here with something from here. So that's why I'm saying all these things. So 2d plus 5 and 2d plus 5. Please cross it out and put 1. Cross it out and put 1. Anything else? 2d minus 5 from the bottom with 2d minus 5 from the top. There is nothing else we can do here. And you will not go back to distribute anything. You will just keep them side by side. D plus 5, D minus 5 over 5D minus 1 and 5D plus 1. This is the final answer, including the restrictions. If someone says to you that the final answer is this, without the restrictions, you have to say no. Because in all these situations, this expression doesn't even exist. Okay, that was a very long problem. It took us, I don't even know. Now, I would like to review complex rational expressions before we look at equations. So anything that appeals to you, this is from your book. It's on page 65. I will always, if we choose a problem from the book, I will put the page so you can go back to it in the book if you need to. So I would like to look at, by the way, how do we divide fractions or rational expressions? Should we do it? Yes. We'll flip the second one. Okay, good. Should we just do a quick division or not?
Sure.
Okay, let's do a quick division before we add and subtract. Okay, so I'm gonna choose something that is not as long, like 26. 26 on page 64. And this is x squared minus 9 divided by x squared plus 6x plus 9 and divided by x squared minus 2x minus 3 over x squared plus 2x minus 3. With your permission, I changed q into x only because you had difficulties with 5, my not good looking 5, and I'm sure you'll have difficulties reading my q. So I got your permission. Okay, so the numerator is very clear. How will I factor it? Right. I'm assuming that we are all on the same page with this. Okay, now the denominator. So see, that's what the strategy is so important for. And do not skip any of the steps. This is a trinomial. It's in descending order. It has no greatest common factor. It does not have a negative coefficient, leading coefficient. Special product, the answer is yes. Because the first is a perfect square and the last is a perfect square. And what do I expect to get? X plus 3 squared, but I still have to check the middle term. But it will be 2 times the first times the second. Okay, so please do not skip any of those steps. So how will you factor then x squared plus 6x plus 9? Very good. It's a perfect square, and it's exactly this special product that we just discussed. It's x squared plus 6x plus 9, which is x plus 3 squared. That's why I wanted to review that first. Any questions? Okay, so for now, copy the division symbol and tell me how you factor the numerator and the denominator. Again, descending order, greatest common factor, negative leading coefficient, no. A special product, no, not this time. But the leading coefficient is 1, which makes it much easier. I don't have to change it into 4 terms and apply factoring by grouping. So how will I factor the x squared minus 2x minus 3? Say it again.
X minus 3x plus 1.
X minus 3x plus 1. Very easy to check. X squared minus 3x minus plus x is negative 2x and minus 3. And? Very good. Perfect. We need restrictions. We can flip before we write the restrictions. And we will write more restrictions after we flip. So for this one, we will have x not equal. I don't have to copy it again. It's already here. And what about that one? Correct. I am allowed to simplify each fraction by itself, but in a division, I'm not allowed to simplify across. Only in a product, I'm allowed to simplify across. Careful with that. So then the next step would be, yeah, why not? I'm going to get rid of this one from the top and one from the bottom. I'm simplifying the function by itself, the fraction by itself, right? Good. Nothing else works. So x minus 3, x plus 3, and I flip into x plus 3, x minus 1, divided by x minus 3, x plus 1. Now I have 2 new factors in the denominator. These 2 new factors cannot be 0. So I have 2 more restrictions to add to the list. Can anyone give us 2 more restrictions? One from here. And one from here. Next. Very good. This is extremely important moving forward. And you'll see why. Any questions? Now we are allowed to simplify. X plus 3, put 1. X plus 3, put 1. x minus 3, 1, x minus 3, 1. And the final simplified form is this. Not without the restrictions, though. The correct final answer is x minus 1 over x plus 1 only when and if x is not plus or minus 1 or plus or minus 3, please.
And can we apply restrictions after simplification?
Say it again?
After simplification, can we apply restrictions after simplification or like?
No, because you lost the factors.
Mm.
You don't have restrictions anymore. They're gone. You have to state restrictions before you simplify. The factors are gone. What are you going to state restrictions on? You're only going to say restriction x equals not equals -1. But this is your expression. You're simplifying that, not this. You're simplifying the original problem. And the conditions, the restrictions have to be on the original problem, not on the final answer. Who cares about the final answer? Once the factors are gone, you're not going to have restrictions to write. So you have to write the restrictions before you simplify. It's mandatory. So for example, what about x over x? What is the answer?
1.
No. It's 1 only if.
X is not.
Exactly. So once you have 1, you're not going to have anything to write restrictions on. What is the restriction on 1? There is no restriction. That's why you have to state the restrictions before you simplify. Is that clear? Yes? Okay, perfect. Let's look at an addition or subtraction of rational expressions. Let's say 38. So let's write a note if there is any discussion or any doubt. Restrictions on the variable or variables are stated before simplification. Please remember, restrictions are stated before you start crossing out factors. Okay, let's look at 38, and this is from page 65. X minus 1 over x plus 1 minus 2x plus 3 over 2x plus 1. Well, obviously, multiplying and dividing rational expressions is easier than adding and subtracting them. Multiplying fractions is easier than adding and subtracting fractions. Okay. So we cannot add fractions unless they have the same denominator. I have to state 2 restrictions, and then I have to find the least common denominator. So what is the restriction for a first fraction? For the first fraction to exist and not be undefined, x must never be -1. And for the other one, must never be -1/2. So this will be part of the simplified form. The answer depends on this. Okay, perfect. So can anyone give us the least common denominator? Okay, so if the least common denominator is x plus 1, I have to explain something and I'll come back. So if I have 1/2 plus 1/3, what is the least common denominator? Write 6. I want to write 5. Why 6? Or I want to write 3. Why 6?
I think I was just thinking it through only because 2 times 3 is 6. So.
It's the lowest number that the 2 terms have.
Exactly. Did you hear what your colleague said? So, of course, the answer is it must be a product somehow, or it can be the lowest number that the other one is divisible by, right? So in this case, 2 and 3 are prime numbers. So the least common denominator must be 6. 2 was multiplied by what to get 6? Okay, we have to multiply the top by the same thing. Same quantity, same number. 3 was multiplied by what to get 6? I have to multiply the numerator by the same number I multiply the denominator. Otherwise, I change the value of the fraction. So then 3 times 1 is 3. Copy the sign, plus 2 times 1 is 2. So the answer is 5/6. Now, if I say this, I will only have an answer for this. 3 times 1 is 3. So I'll multiply the top by 1. But what will I do with 2? 2 times what is 3? Doesn't exist. So the least common denominator to be just one of the two factors, it will never happen unless they are the same. So the least common denominator has to have all different factors you see in the denominators. If we have 10 denominators and they all have 10 different denominators, if we have 10 fractions and they all have 10 different, we have to have 10 factors in the denominator. So, because remember, we are looking for two answers here. We are looking for this answer and we are looking for this answer. If one of the answers doesn't exist, then I know I chose the incorrect least common denominator. So now x plus 1 times what factor is this? The answer is 2x plus 1. And 2x plus 1 times what is this? So the answer is x plus 1. We must have two answers, right? One for the first fraction and one for the other. Okay, now be very careful what happens next. We need to multiply these, but we have to FOIL. And we need to multiply these, and we have to FOIL. I want to show you one thing that I don't want to write. But if you know what you're doing, it's legitimate, and you can use it. But I will not do it. I'll tell you why. So this is what we are trying to do, right? The reason why I don't write this is because some of my students are tempted to do this. It's tempting, isn't it? But I can't do that, right? Because this is a factor, but it's part of a term. And this is a factor, but this is a term. So that's the reason why I never write this. If you know what you're doing, you can. Instead, I'm going to continue from here. I write x plus 1, 2x plus 1, and let's multiply together. X times 2x. X times 1 plus x. Negative 1 times 2x. And negative 1 times 1. Now I have to be very careful because I have a negative sign that will get distributed to everything that follows. Everything. 2x times x with minus in front. 2x times 1. 2x times negative 1. 3 times x with minus in front, and 3 times 1 with minus in front. So in other words, I'm writing it out from the beginning instead of writing it side by side and maybe be tempted to simplify. It's not the only method. If you know one you're happy with, please use it. So now, what is the next step? The answer is combine like terms. Well, luckily these two go away. Then we have negative 5x and another negative x. So this is negative 6x. And then we have a negative 4 over x plus 1, 2x plus 1. Did I miss anything? So this is a negative 4. Oh. No, yeah, that's correct. So negative 5, negative 6, negative minus 1. What I recommend is factor out negative 2 and get 3x plus 2 over x plus 1, 2x plus 1, only when these restrictions are fulfilled. For x not equal negative 1 and negative 1/2. This is the correct final answer. Any questions, please?
Would it be wrong if we didn't simplify it all the way down, or would we go to
You mean factoring out -2?
Yeah.
Yeah, it's not incorrect. However, when you get to calculus, you'll see how important that step is. Yeah, it's very important. Okay, one complex rational expression, and then we are ready for equations. So let's do this one, which is 49. They recommended that, so let's do 49. Any questions for me, please? Any questions, anyone? Can you keep up? Any questions? The breaks are at your disposal, right? So you can always say, wait, or show me another example, or whatever you want to say, right? I don't want to lose anyone. So 49, and this is on page 65. And we have 2c over c plus 2 plus c minus 1 over c plus 1. Everything over 2c plus 1 over c plus 1. This is what it's called a complex rational expression. It's complex because it has operations with fractions at the top. Then it could also have operations with fractions at the denominator. This one doesn't. But it has a sum of fractions at the top. That's why it's called complex. So like we did before, nothing different really. Let's find the least common denominator for the top, and the denominator is just 2c plus 1 over c plus 1, and you will give me 2 restrictions for now. Because I see 3 denominators, 1, 2, 3, but 2 are the same. So the 2 restrictions you will give me are c not equal -2 and c not equal, very good, -1, excellent. You will give me the least common denominator for the top as being excellent. C plus 1, C plus 2. Do you all see that? Yes? And I call these adjustments. What will you adjust the numerator of the first fraction by? What it doesn't have. So the least common denominator is C plus 1, C plus 2, and it has C plus 2, well, it doesn't have C plus 1. And the second one has C plus 1, and it doesn't have. So this is C plus 1, and this is C plus 2. Now slowly, can anyone dictate the top? Two c squared plus, excellent, plus, careful here, we are foiling this, c squared plus 2c minus c and minus 2. Very good. Are you with me? Do we all agree with this? Yes?
Yes.
Okay, perfect. So let's combine my terms and write and flip the denominator at the same time. So we have 3c squared, and we have plus 3c and minus 2 over c plus 1, c plus 2 times c plus 1 over 2c plus 1. And now there is an extra restriction here. C cannot be -1/2. Now, I do have to ask myself if this is factorable. So 3 times -2 is -6. So I want 2 numbers whose product is -6 and whose sum is 3. Right? We have to try. Because it could be simplifiable, right? But the 2 numbers have to be one positive and one negative, and 6 is only -2 times 3 or 6 times 1, right? And none of them will give us a 3. 6 and 1 or 2 and 3 will never give us a 3. So this is not factorable. So the only simplified factor will be this, nothing else. So 3c squared plus 3c minus 2 over c plus 2, 2c plus 1, only when these restrictions are fulfilled. That is part of the answer. They may not say that in your book, but that's the correct answer. Okay, I think we're done with this and we can go to that handout. So let's choose from the handout. This time we want to solve equations. So feel free to choose whatever you want so we can put this handout aside. And you will practice and check the other ones, right?